Hello students, so let's try to solve one more question from a book of quantum mechanics, that is Introduction of Quantum Mechanics from David J. Griffith. And it's a very interesting problem, very nice problem actually. And here we have to also learn how to use Gaussian, how to use the basically concept of Gaussian. So first let's go for this particular problem. So in this particular problem, it is given that in the ground state of harmonic oscillator, what is the probability of the finding the particle outside the classical allowed region? And it is also given hint that classically the energy of oscillator is half Ka square, where A is the amplitude, so that classically allowed region for an oscillator of energy E extended from minus root under 2e m omega square to plus 2e m omega square. And to solve this particular problem, we have to use the concept of error function or normal distribution also. So we will discuss this problem in a very detail, but before that, let us try to go for what is this particular error function. So I have another slide, and in this slide, you can see that error function is nothing. Error function of z is equal to 2 by root pi integration 0 to z e to the power minus t square dt. If you have this type of function, then it is what? Error function. And once you will going to plot this particular error function, that will, the domain and range is from -1 to +1. And you can have this type of plot, and it's almost antisymmetric plot, you can say. And in this particular problem, to solving this particular problem, we have to find what is the value of error function at z is equal to 1. So here we will get this value is almost 0.84 or 85, you can say. So from this graph, we can find if error function z, that means 2 upon root pi 0 to 1 e to the power minus t square dt is equal to something 0.85. So we will use all this concept. So let us try to solve this problem step by step. And in this problem, we have to use a little bit of classical concept as well as quantum mechanical approach to solve this particular problem. So let us try to go for this one. So in this problem, we have to just go for this one. So, okay. So let us try to go for this one. Okay. So what is this? The potential is simply half m omega square x square. And if we are talking about this particular potential, then this is a parabolic in nature. And ground state energy E is equal to h cut omega by 2. And if this is my ground state energy, the probability distribution, so this is my Vx versus x. So if we are going to plot the probability distribution, so for that we need a wave function. The wave function is pi naught, and this value is equal to m omega upon pi h cut to the power 1 by 4 e to the power minus m omega x square upon 2h cut. And obviously x is between minus infinity to plus infinity. And what will be the probability density? The probability density rho x is equal to mod phi naught x square, and this value is equal to m omega upon pi h cut to the power 1 by 2 e to the power minus m omega x square upon h cut. So we have to take care of this thing. So this is all about our probability density. And this is from minus infinity to plus infinity. And once we are going to plot this particular probability density, then this probability density is something like this. So this is given my probability density. In this problem, what we have to do, we have to find that what will be probability that particle will be into the classical forbidden region. So we have to find this one. So outside the classical allowed region. So this region is the classical allowed region. These regions, so this area under these curve. So area under these curve is what? Classical forbidden region. And we have to find what will be the probability such that particle will be into the classical forbidden region. So before going to that, what we have to do, so we can see that this area and this area is symmetric. So we can easily find that rho x dx, that will from x naught to infinity and 2 times. So we have to find this one. So this will just tell you probability to find particle, probability to find particle in classical forbidden region. So this is integration we have to do. Now the whole concept is that what will be this value of x naught and how we will calculate all these integration. So let us try to go for this one. So when we are talking about the classical forbidden region, so again we are here. So this is my potential and the energy is h cut omega by 2 for the ground state. And we know that E is equal to nothing, px square upon 2m plus half m omega square x square. And this point is nothing known as what? X naught. And this x naught is also known as turning point. And this x naught is also amplitude. So what is beautiful part of this turning point and amplitude? Here you will find that momentum will be 0 and you have maximum displacement. Because total energy is conserved, when kinetic energy will increase, the potential energy will decrease, and vice versa, when potential energy will increase and kinetic energy will decrease. So what will happen? So the momentum px is going to 0 at x is equal to x naught. So what we have? We have 2e upon m omega square is equal to x is equal to x naught. Now we will, and here we have root under plus minus all these things. So we will go for minus is this point, plus is this one. So this one is minus x naught. And this region is allowed region, this region is forbidden region. Okay, and we have E is equal to h cut omega by 2. So we have plus minus h cut omega by 2. So we have h cut upon m omega, that is our x naught. So now we have to go for this particular integration. So what we have to do? We have to go for 2 times x naught is nothing but root under h cut upon m omega to infinity e to the power minus m omega x square h cut dx. So we have to, this is the value that will be particle into the classical forbidden region. So we have to just go for this one. So let us try to calculate this particular integration. So probability to find particle in classical forbidden region is given by x naught to infinity 2 times, and here we have e to the power minus, and this is rho x, so we have to just go for rho x dx. Okay, and what will be this value? So this value is equal to 0, and this value is equal to h cut upon m omega to the power infinity, and this is m omega upon pi h cut to the power 1 by 2 e to the power minus m omega x square upon h cut dx. So now we will convert it into error function. So what we will do, we will just put m omega upon h cut, this value into x must be equal to t. So dx is equal to root under h cut upon m omega dt, and x is equal to this value. When x is equal to x naught, t is equal to 1. You can just check. So when we will put x is equal to x naught and that value is equal to h cut upon m omega, then t must be equal to 1. So what we will get? We will get that this value is 2 upon root pi is there, and here we will go for 1 to infinity and e to the power minus t square dt. We can put all this value here, m omega h cut and h cut m omega will cancel and we will get this value. So we have to calculate this particular integration. So let us try to go for using error function to get this particular integration. So let us try to go for this. So we have to calculate the value that is 2 upon root pi integration 1 to infinity e to the power minus t square dt. So finally we have to get this one. And we all know that 1 upon root pi integration minus infinity to plus infinity e to the power minus t square dt must be equal to 1. And this is just a even function, so we can write 2 upon root 2 pi 0 to infinity e to the power minus t square dt. That value is equal to 1. And we can just write down this whole integration into two parts. So what you will get? We will get 2 upon root pi integration 0 to 1 e to the power minus t square dt plus 2 upon root pi integration 1 to infinity e to the power minus t square dt must be equal to 1. And you can just check from the error function. We can use here the concept of error function. This value from this particular graph, when we are seeing this particular graph, this value is equal to 0.85 plus we have to calculate this value. So this is 2 upon root pi 1 to infinity e to the power minus t square dt is equal to 1. And then we can get the value. And what is this value? 2 upon root pi, that value is 1 to infinity actually. So this is our value 1 to infinity e to the power minus t square 1 minus 0.85, and this value is equal to point. So we have this particular 1.158 something, we can get this particular value. So this is our answer. So students, there is no need to do any calculation because we have error function table. And once you know the concept of error function, you can easily use it. Only beautiful part is that how we can make the thing dimensionless. This is the beautiful thing. And how that what is meaning of classical allowed region, what is meaning of classical forbidden region, and how we can go for this particular calculation. So students, I suggest you that do this problem with yourself and try to understand the basic of this particular error function, because in general we have solved question where we have integration from 0 to infinity or all these places, but here the integration is all about some constant value to infinity for the Gaussian. Then yes, error function is one of the beautiful concept that we can use this. Thank you.